Hello, here is the solution for question number 7 on page 147. We have a locomotive of a certain mass. It is pulling two railway cars. We also have masses for that, and they're connected through a locking mechanism. We are given the maximum force that the locking mechanisms can withstand, and based on that, we're supposed to see what the maximum acceleration of the train can be. So if you look at the picture, we can see is that um, we have two railway cars back here, and then we have the locomotive up front. Really, what's happening here is this locomotive is pulling right at this point, and we're treating this as a single unit. So these two cars are actually, because they're so connected, they act as a single mass. So we can calculate what our mass for that will be. And if we do the free body diagram, we can analyze what kind of forces are acting on that total mass. So here's our free body diagram. Um, we have normal force acting up. We have gravity acting down. And the only force that's the overall net force, the only force that's actually acting on these cards is in this direction, where the locomotive is pulling. So you could say that this F net force is the only force acting um, because in the question it says assume that the friction is negligible, so there's nothing acting in the opposite direction, and these two um, don't really have any effect on what's happening in that forward direction. And I'm assuming that the forward direction is to the right, which in the direction of the locomotive. Um, so if you know from the Newton's laws that F net is equal to mass times acceleration. However, in this case, we're looking at the total mass of the two railway carts. And then it's also going to be the acceleration of those carts, and that is going to be equal to the F net of the F net from the free body diagram that we got. Now, we know that the maximum force that can act on these carts is 2.0. So it's 2.0 times 10 to the power of 5 newtons. That is our F net. So that is the maximum force we can have. Um, and so the first thing we should probably do is to find a total mass, which would be the mass of railway cart 1 plus mass of railway cart 2, which is 5.0 10 to the power of 5 plus 3, 6 10 to the power of 5, which turns out to be 8.6 10 to the power of 5 kilograms. There we go. And we are going to use this mass over here. So our F, like we said, it's 2.0 times 10 to the power of 5, and that's going to be equal to 8.6 times 10 to the power of 5 times acceleration. If we isolate acceleration, we're going to kind of put it over here, and it is 2.0 times 5 over 8.6 times 10 to the power of 5, which turns out to be 0.23 meters per second squared. And we can attach direction in this case. Therefore, the acceleration is going to be 0.23 meters per second squared. You can either put to the right or forward. There we go. So you can see that all of them are moving with the same acceleration. So the cards are going to be moving at 0.23, and the locomotive is moving at 0.23 meters per second squared. Based on our calculation, we exclude the locomotive because that is what's applying that force to the rest of to the other cards, right? And we're using them as a single unit because we are assuming that this locking mechanism is locking them together and there is no stretching or compressing of that connection of the locking mechanism. That's it. Thank you.